Hello, good morning, everyone. Good morning, grade 10. So, I'm here again, teacher Lenzo, and I will teach you again another idea regarding in our subject. Last time we discussed about the Snell's law, which is discuss the refraction index of the light in a mirror equation. Okay, and now I want you to welcome again in our synchronous day because it's time for our synchronous lesson, which is you will watch only a video like this, okay? And to for you to answer the activity that I prepared for you. So let us continue. So today I will discuss to you about the magnetic field mapping. All right. So sinabi natin last time, no, last ago na nag-aral kayo in your level, no, you already discussed the different electromagnetism, which is the composition between magnet and electricity. All right, or the interaction between the magnetic or the magnet and the electricity. In this topic, we will discuss how to map how to map the magnetic force in our area. Like for example, in our we have experiment later on, and on that experiment, it will explain to you how the magnetic force attracted to each other, the north and the south pole. But for now, let us discuss what magnetic mapping is. So magnetic mapping. So we have magnetic field, all right? So when we say magnetic field, it is the region around the magnet where it is or where it exhibit a magnetic influence. Okay? This field form a loop around a magnet that is more concentrated at the opposite poles. This means that the magnetic field is strongest at the poles. So we have different magnet that can be used. One is the bar magnet. Okay, it shapes a rectangular shape. Okay, the next one is the horseshoe magnet. Okay, letter U. Okay, and the straight conductor only a plain straight conductor. And next one is the coil. Alright? So what is magnetic field line? So these are the lines that show the direction of the magnetic field around the magnet. This line runs from the north pole to south pole of the magnet. Okay? That's why a compass needle always point away when it is placed in the north pole and point toward south pole. So magnetic field lines are more concentrated at the poles of the magnet. Later on, malalaman nyo yung four properties of magnetic lines or magnetic field line. So, magnetic field lines, also detecting magnetic field lines in their direction, help in understanding direction and direct them to their way. So, like for example, the unlike pole and the like pole. Okay, pag unlike pole, attraction, nag-attract to each other, while like pole, repulse or repulsion ang nangyayari. Okay, hindi sila dumidikit. While the unlike pole, dumidikit sila, can attract each other. Okay? So this is the magnetic line field of the U magnet. All right? Like as a big earth, no? Na kung saan tinutumbang natin, earth is a big ball of magnet. In the previous lesson, you've learned that when a magnet hangs freely, it always points to the north direction. Same when we use a compass, it always points to north. Magnet behave that way because Earth itself is like a big ball of magnet, which is complete with vast arcs of magnet force. This force is called geomagnetic fields. Again, that kind of force is what we call geomagnetic field that surround our planet. So Earth, a big ball magnet. This wonder was discovered and recognized by English physicist, which is William Gilbert in 1544 to 1603. Today, scientists believe that the source of magnetic field lies on the deepest layer of the Earth, which is the molten core. As what we tackled, now what we discussed last time, no, in our the different layer of the earth, no, na-discuss ko rin sa inyo ito, which is the magnetic force or magnetic field of our earth. Within the inner core, they believe run power electric current that ultimately create the geomagnetic field. And since the current in the core is continuously moving, they still threw or thought of the possibilities that the Earth's magnetic poles are also changing. So, meron tayo tinatawag na magnetic chaos. Ano ba yung magnetic chaos? So, magnetoreception has been detected in animal. Okay, may na-detect silang magnetic sa isang animal. Okay, kundi sa baka, hindi lang sa baka, which is turtles, bird, and etc. So, magnetoreception is the ability of an organism to detect magnetic field to perceive direction, location, or altitude. But in 2018, Heineck Burda, a zoologist at the University of Duisburg in Essen in Germany, studied as a satellite image of domestic cattle which seem to prefer their bodies along Earth's magnetic field lines. Sheep, deer, and cattle tend to stand with their backs to the wind to avoid the cold breeze, but based on the satellite image captured, even sunny days, they all tend to face in the same direction. They prefer to align themselves from north to south direction because of this phenomenon. Many themes were created to prove that this is true and look for other animals that have magnetoreception. So, what's in the field? Okay? They can be good or bad. Okay? They can be good or bad people, so you should be mindful and ready all the time. You need to be vigilant and careful in all you do. Be observant on what's in the field. This is the reflections that we need to ourselves. Okay? Like a magnet, marami ding nakapaligid sa atin. Like think that all the people that surround you is a magnet, no? You can attract and you can repulse to them. Okay? So if the person is good, okay, you can attract. But the person is not good, you can repulse from them. All right? So now I have here a video regarding the experiment on how we create the magnetic lines using the bar magnet, okay? And what is the four properties of magnetic field lines? So let us watch
It's
this.
probably safe to say that you have a very good idea of how the magnetic field of a bar magnet looks like. But do you know the four important properties of magnetic field lines? To find out, let's begin by plotting some magnetic field lines. We need a pen, plotting compass, and a magnet. My magnet doesn't tell me which is the North Pole and which is the South, but we'll find out soon. Place your magnet in the middle of the page and trace around it. Place the plotting compass near the magnet. Mark the direction that the compass needle points by drawing a dot. After the first plot, move the compass so that the back of the needle lines up with the dot. Repeat this until you reach the end of the magnet. Join the points together to show a field line. I'll also draw an arrow here to show the direction that the needle is pointing in. I'll do all of the above again with another starting point. Looking at the field that we've plotted, we can figure out the four main properties of magnetic field lines. Number 1. Magnetic field lines never cross each other. They never overlap. Number 2. They always point from the north pole of the magnets to its south pole. North into south, so that must mean that this is north and this is south. Number 3. They are continuous. The only reason these lines have been cropped out here is because I've simply run out of space. Number 4. Where the lines are closer together, the magnetic force is the strongest, and that's at the poles of the magnets.
So that's all about the magnetic field. Okay, field mapping and how to map the magnetic force using the bar magnet, U magnet, and plane coil and core. No? So now I think that you can answer your activity using this video. So that's all for today. God bless you, and I hope you enjoy and you learn from me. Thank you very much, and God bless you.